All right, let's talk about JSON. You see, it's just text, but it's also kind of the unofficial language of the modern internet. It's what's powering, well, pretty much everything you use. APIs, web apps, mobile apps, they all speak JSON. It's how servers talk to browsers, how services talk to each other. So yeah, understanding it, not really optional anymore. It's fundamental. So to really wrap our heads around JSON, we've got to start with the basics. And the best part? There are only six, core building blocks. That's it. Everything else is just how you put them together. Okay, check out this diagram. This thing right here, it shows every single thing that can be a legal value in JSON. And what's wild is just how simple it is. Seriously, everything boils down to one of these paths. You've got your two structures, objects and arrays, and then 5 basic data types: strings, numbers, and those 3 little literals: true, false, and null. That's the whole shebang, the entire JSON universe right there. All right, let's quickly hit the most common primitives. First up, strings. Super simple. It's just text, right? Any Unicode characters you want, but they have to be wrapped in double quotes, not single quotes. That'll break things, always double. Then you've got numbers, and they're just numbers. Integers, decimals, positive, negative, doesn't matter. There's no weird distinction between integers and floats. A number is just a number. Easy. And to finish off the primitives, you've got the 3 literals. You've got true and false, your standard booleans, and then null, which basically just means the intentional absence of a value. It's a way of saying, hey, there's nothing here on purpose. And boom, with that, we have all our basic ingredients. So we've got our basic Lego bricks, right? The little pieces. But how do we actually build something with them? Well, that's where objects and arrays come into play. These are the 2 fundamental ways you can organize all that data in JSON. Just take a look at this blob of text. Believe it or not, this is a perfectly valid JSON object. A computer can choose through this in a nanosecond, no problem. But for us, for a human, man, it's a mess. Trying to debug this or even just figure out what's going on at a glance, it's a total headache. Now look at this. It's the exact same data, but we've just added some formatting, some white space, and suddenly it clicks. This is what people mean when they say JSON is human readable. It's also a perfect time to point out something really important. What you're looking at on the screen is JSON text. It's a string. It's only when a program parses it that it becomes a real data object you can work with. The text is for sending across the wire. The object is what you use in your code. Those curly braces you see, they define the object, which is really just a bunch of key value pairs. So the big question, when do you use an object and when do you use an array? Honestly, the rule of thumb is pretty simple. You use objects with their named keys when you have an unordered collection of properties. Think of it like a dictionary. You use arrays, the ones in square brackets, when what you have is an ordered list of items where the sequence matters. Okay, so how did JSON get so huge? I mean, why is it everywhere? To really get that, you have to look at the behemoth it went up against and, for the most part, replaced on the web, XML. I mean, just look at this side by side. On the left, you've got a simple menu described in JSON. It's clean, it's direct, you get it instantly. On the right, the exact same data in XML. Wow. The XML version is just drowning in tags. You've got opening tags, closing tags, so much noise. It works, sure, but it's way more verbose and a lot heavier to send over the network. And look, this isn't just about the syntax being clunky. It's about a fundamental difference in philosophy. XML was designed to mark up documents, like articles with paragraphs and headings. JSON, on the other hand, was born specifically to represent data structures. One's for documents, the other's for data. So when all you want to do is send some data to a browser, XML's whole ecosystem of schemas, namespaces, and style sheets, it was just massive overkill. And this graph, this tells the whole story. It's Google search interest over time. Blue is JSON, red is XML. You can see right around 2013, JSON just takes off and never looks back. It's pretty clear. Developers voted with their keyboards. Simplicity won, hands down. Okay, so enough history. How do we actually use this stuff in a modern web app? Let's walk through the process of taking that string of text from a server and turning it into something useful in our code. These days, it's actually incredibly simple. In JavaScript, you'd use something like the fetch API to ask a server for some data. What you get back is a stream of text. Then you just call the .json method on that response. And that's the magic right there. It safely and efficiently parses all that text for you. What you get out is a native JavaScript object ready to go. You can start working with it immediately. But man, it was not always this easy or this safe. Not by a long shot. Back in the early days of the web, before we had all these nice modern tools, developers had to get really creative. And that creativity, it led to some pretty serious security nightmares. So here's the question that caused all the problems. People looked at a string of JSON text and thought, hey, that looks almost exactly like a JavaScript object literal. Why don't I just, tell the JavaScript engine to execute it as code? I mean, it seems so efficient, right? And the tool for that job was a dangerous little function called eval. But using eval to parse JSON from some server out on the internet is a horrible idea because it doesn't just parse data, it will execute any code you throw at it. So a bad actor could easily slip some malicious code into that string and eval would just run it, no questions asked. Huge security hole. And if that wasn't enough, you also had browser security rules that blocked pages from grabbing data from different domains. So to get around that, developers came up with this clever little hack called the dynamic script tag. Basically, they would programmatically add a new script tag to the page that pointed to an external URL, because browsers let script tags load from anywhere. It was a really clever workaround for sure, but also super risky. It was a hack born of necessity. All right, let's zoom out and give JSON an honest look. It's not perfect, nobody's claiming it is, and it's really important to get what the trade-offs are. So the critics do have some valid points. For example, there are no namespaces, so you could have key names that clash. There's no built-in way to validate the structure, though things like JSON schema exist now to help with that. And famously, probably the biggest complaint, you can't put comments in it. There's no way to leave a note for the next developer explaining what a piece of data is for. So if it has all these limitations, why did it win? Why is it everywhere? Because its strengths were exactly what the web needed at the time. It's easy for people to read, which helps with debugging. The syntax is so simple that parsers are incredibly fast and efficient. And maybe most importantly, it maps almost perfectly to the common data structures like dictionaries or lists in pretty much every programming language out there. There's almost zero friction to start using it. It was just good enough for the vast majority of jobs, and it turns out good enough is an incredibly powerful feature. When you really think about it, the story of JSON is a fantastic lesson in how technology evolves. It's this perfect case study of how a simpler, more focused tool can totally overtake a complex, feature-rich one, just by being easier to use and better suited for the job at hand. It really makes you wonder, right? What's the next good enough technology out there that's about to do the exact same thing?